So this is the first question. Here it is given. Lambda alpha and lambda p are the wavelengths associated with moving alpha particles and proton. So lambda alpha is wavelength of alpha particle and lambda p is wavelength of proton. We have to obtain the relation between velocities of two particles, for which number one this relation and number two this relation. So when you see alpha particle and proton, so you should go for the symbolic representation of alpha particle, which is helium 24, and proton, which is hydrogen 11. So lower one makes up the charge. So charge of alpha particle is plus 2e and proton is always positively charged. So charge of proton is plus 1e. And upper one makes up the mass. So mass of alpha particle is 4 mass times the mass of proton, 4 mp, and mass of proton is 1 mp only. And if needed, the value of mass of proton will be substituted, which is equal to 1.6 into 10 to the power minus 27 kg. Yeah, then coming to what will be used here, because it is a question related to lambda. So you can pick up lambda equals h by small p, which is momentum, and momentum is further opened as mv. So this is de Broglie's equation. We are making use of this de Broglie's equation, and we will be writing it for one time for alpha particle and one time we will write for proton. Then we will divide. So let us write it out. So we are writing it for alpha. So it will be h. H is Planck's constant, so it is constant. Mass of alpha, velocity of alpha. Similarly, we will write for proton. H is constant, mass of proton into velocity of proton. So now you can divide. So lambda alpha I am keeping up and lambda proton I am keeping down. So lambda alpha is up, so that will be written the way it is, and lambda proton is down, so it will be inverted. So lambda proton I have written this way. So now you can see what will be cancelled. H will be cancelled, so H you can cancel. So H is cancelled. And now let us substitute lambda alpha divided by lambda proton. So it is mp. Mp's value is mp only, and velocity of p is to be found. And then mass of alpha is, you can see it was written as 4 times mass of proton. You should see from the above particulars, and v alpha as it is. So mass of alpha I have opened as 4 times mass of proton. So mass of proton will be cancelled. So what are we left with? We are left with lambda alpha by lambda proton equals Vp divided by 4 times velocity of alpha. And now what is asked? We have been asked the ratio of velocities. So ratio of velocities can be told from here. And now let us see what is first relation. First relation is given as lambda alpha greater than lambda p. It was given. So now you can see lambda alpha divided by lambda p. It will be greater than 1. I have brought lambda p down, so it is left greater than 1. So let us put the value of this lambda alpha divided by lambda p. Its value is this. So let us substitute. It is Vp by 4 V alpha. In place of lambda alpha by lambda p, I have substituted this greater than as it is. 1 is as it is. So now you can take Vp divided by V alpha. 4 you will take there greater than 4. So 4 has gone that side. So this is the ratio of velocities, or you can write it as Vp greater than V alpha. Also you can take that side 4 times V alpha. So this is the answer. Now let us see second part. In second part, lambdas have been given equal. Okay, so lambda alpha has been given equal to lambda proton in second part. So again you can be ready with the lambda alpha by lambda proton, which is 1. Here it is 1. Earlier it was greater than 1. Now you have to substitute the value of this from here. You can say from here. Lambda alpha by lambda proton is this Vp by 4 V alpha. So let us substitute Vp by 4 times V alpha equals 1. This time it is not greater than 1. So your ratio is ready. So this is the answer this time. Okay, earlier it was with this sign and now it is equal. So yes, it has been done. Let us see the next question, which is question number 19. Compare the focal lengths of two lenses shown below if the radius of curvature of curved surface is same in both the cases. So first is this. First is concave, plano concave. One side is plane and one side is concave. So in this you can see circle is getting completed this side. Okay, so this side is negative. Front side is negative. So R1 I'm writing as minus R. But this I'm doing for plano concave lens. Plano concave lens. And R2 is straight. This is straight. This is straight face. So you can write R2 as infinity. For straight lines, radius is infinity. So you can write like this. And now you can use lens maker formula. So using lens maker's formula, it's 1 by F. 1 you can write equals mu glass by mu air minus 1. 1 by R1 minus 1 by R2. Now you can substitute the things like my 1 by F1 will be ready as mu glass is mu glass only, mu air is 1. So it is this. And my 1 by R1 was a minus R and it was 1 by infinity. So 1 by infinity is 0. Okay, so 1 by F1 equals mu G minus 1. And then it is 1 by minus R. And this is minus 0. Minus 0 is nothing. So basically what are we left with? 1 by F1 equals mu G minus 1 and minus 1 by R. And now this minus can come outside because it is in multiplication. Okay, those who are weak in maths, they should be very careful. So you can write it more organized way, like 1 by F1 everywhere. It is minus mu G minus 1 and upon R. So this is my first equation. Now let us pick up the diagram once more and see for plano convex. Convex. Plano convex. So let us see that diagram. So it is this way. So you can see first side is straight. So R1 is infinity. And second is this way. Circle is getting completed this way only. So it is minus R. So you can write it as, but that is R2. Okay, so diagram has been given as this. First side is this. So you can write R1 as infinity. And R2 circle is getting completed this side only. So R2 will be written as minus R. Earlier in first case, it was given this way. First diagram was this. Okay, in that R1 was minus R and R2 was infinity, but here it is first surface is straight line, plane, so R1 is infinity. So you can substitute now 1 by F2. Again, we are using lens maker's formula. Mu G minus mu air, sorry, mu G by mu air minus 1 and 1 by R1 minus 1 by R2. You can substitute the values properly. R1 is infinity here and R2 is minus R. So let us substitute. 1 by F2 equals mu air is 1 once again. So mu G minus 1 and this is 1 by R1 is infinity and this is minus and minus R. So you can see this can be written as 1 by F2 equals mu G minus 1 and 1 by infinity is 0 and this is minus minus plus 1 by R. 0 plus 1 by R, 0 is nothing. Okay, so 1 by F2 can be written as mu G minus 1 into 1 by R, and again you can write it properly if you wish, mu G minus 1 upon R. So this is my equation number 2. And what was my equation number 1? Let us see that too. My equation number 1 was this. 1 by F1 equals minus mu G minus 1 upon R. So you can write that down here. Now I'll write equation number 1, which was 1 by F1 equals mu G minus 1 and there was a minus n upon R. So this is equation number 1. Now I will divide both. So how to divide? Let us divide 2 by 1 or 1 by 2 as you wish. So suppose I am writing 2 by 1. So 2 should be written as it is, like this is 1 by F2 and this should be pultoed and then this side should be as it is, mu G minus 1 upon R, and it should be written opposite. That means R upon this Okay, now mu g minus 1 is cancelled and r is cancelled. What are we left with? F1 by F2 equals minus 1. This minus is left. So what is the relation or ratio is clear, otherwise you can write it this. So we were asked to compare the focal length, so we compared. Okay, so that's all you can write like this. So this question is 21's or part. Okay, glass beaker of height 10 centimeter. You have to read this question number of times to get the clear picture of what are the things happening in this. So a glass beaker of height 10 centimeter completely filled with water. Water's refractive index has been given as 4 by 3. Has a curved bottom which is silvered as below. Silvered means now it is acting as a mirror. So this is the bottom which is given. Okay, this is concave mirror. So you can see the coin is placed here. It is at the depth of 5 centimeter from the top layer of the water. So this is the distance of coin from this mirror is 5 only because the total height is 10. So this that will act as U. U for the coin is minus because it is in front of the mirror and this distance is 5. So U is easy to calculate. U is there. Actually, I need to calculate the focal length of the mirror. So focal length is to be calculated and we can use mirror's formula. So this much at least we all can do V 1 by V plus 1 by U and U we can substitute. The question depends upon V. Okay, we need to find out V. So we have to read this very carefully. The plastic coin remains submerged in water at a depth of 5 centimeter that we have considered. An observer sees the coin in the water and its image in the mirror. Coin in the water and its image in the mirror. And the mirror is, if the image formed by the curved mirror is seen by the observer at a distance of 15 centimeter from the surface of water. So observer is seeing the image at a distance of 15 centimeter from the surface of water. Please remember that what observer is seeing is the apparent depth or height, apparent depth of image formed by the mirror. So this is not V. This is apparent depth of the image formed by the mirror. This will solve the confusion. This 15 centimeter, the observer is seeing the image at a distance of 15, but this is not the V. This is apparent depth of the image. So you have to find out the real depth of image to find out V. What will act as V? So you should use the formula mu equals real depth by apparent depth. Real depth by apparent depth. So apparent depth to be substituted as 15 and mu is 4 by 3 of water that they have given. Now real depth of image will come. So real depth of image will come. Image formed by the mirror. So this is 20. Real depth of the image of the coin comes as this. So this is real depth of the image. Real depth of image formed by the mirror is 20 centimeter. So now you can find out V. Okay, 10 from above and then 10 behind the mirror. 10 is depth of water which is 10 centimeter. So 10 behind the mirror. So you can see V is 10. Okay, 20 is 10 plus 10. So this is mirror. मिरर के पीछे 10 सेंटीमीटर पीछे वाली साइड इज पॉजिटिव सो दिस इज V is this and U is -5. Okay, coin actual लेंगे which is at a distance of 5 centimeter from the mirror, so it is U is सामने वाली साइड is minus, so -5 and V क्या है, the observer is seeing the image at 15 centimeter but this is apparent depth of the image. We have to reach to real depth of the image which was coming to be 20. 20 is bifurcated as 10, the entire depth of the water, and 10 behind the mirror. So this is V. Now you can substitute in mirror formula. 1 by F equals 1 by V plus 1 by U, and you can find out the focal length. So this is 10 and this is 5, and then you can take the LCM and solve it on your own. So yeah, this was an important as in you have to understand the question by reading the question multiple times and you have to make understand yourself that what observer is seeing is the apparent depth of the image. So you have to find where the image is actually formed to calculate V. This is question number 21. So in this question you can see The image below shows a setup of a device that is used to increase the diameter of light beam from a laser. So you can see they are increasing the diameter. Earlier, this was the gap between the incident rays, and now this is the gap. So they have increased the angular size of the object or the light beam. So we have to show how a combination of convex and concave lens. Right now they have used both convex and they are using both the convex lenses to increase the diameter of the beam. Okay, earlier the separation was this, now the separation is this. So they have increased the diameter of the beam using two convex lenses, and now they are asking us to use a convex and concave lens. So let us understand what is there in the picture. In the picture, what they have done, they have inserted a parallel beam of rays. Okay, and of course, it is a converging lens, so rays will meet at focus. So this is focus of first lens, f1, and now this point is also the focus of second lens. Okay, so it means for second lens, the object is at focus. So again, image will be formed at infinity, and you are getting a parallel beam of light only, but with the increased separation. So this is how they have used these two convex lenses. We have understood the question. Now, what is the setup that they have used given in the picture? That the separation between the lenses is f1 plus f2. One thing is this, and f1 is also this f1, which is the focal point. The focus of first lens is also the focus of second lens. So this is the arrangement that they have used, and now we have to tell one concave and one convex. So you can use a concave lens, make parallel rays incident on it. Okay, this is incident beam and it will be refracted this way because it is a diverging lens. It means the rays are coming from its focus, or seem to be coming from. This is f1, and now this point also should be the focus of second. Let us see, it should be the focus of second lens, which is convex, so that if the object is at focus, for second lens, object is at focus, rays are coming from focus, so it can also produce a parallel beam of light once again. So what is the setup? This is the setup. You have to write this point as f1 and f2, and then what is the separation between the lenses? This is entire is f2. Okay, and this is f1. Again, let me show by different color. This point is both f1 and f2. f1 for first one, so this is f1, and now this point is f2 also, so this entire length is f2. So what is the separation between them? f2 minus f1. Separation between the lenses should be f2 minus f1. This has to be written with this diagram. This diagram means proper diagram. This is question number 20. What is given in this? Two copper wires, P and Q of same area. So area is same. Area is same. They are joined in parallel. Parallel means voltage is same. And then the combination of wires connected across the battery of potential difference V. Battery's potential difference V. If the length of wires are in ratio of this and this, we have to find out the ratio of drift velocity. So let us see. Two wires having P and Q, they have same area. So area 1 is A and area 2 is also A. They are joined in parallel. So V1 is V, voltage is same. V2 is also V. And length, you can see length are in ratio of 1 is to 2. So L1 is 1L and L2 is 2L. We have to find out the ratio of drift velocity. So VD1 is equal to question mark, or VD2 is also question mark, as in the ratio is to be found. Now because they are connected in parallel, so voltage is same, we can make use of this fact. So voltage is same, so we can use V1 equals V2, and V is open as I1 R1, and this is open as I2 R2. Okay, now I can be open as NEAVD. You know the relationship between current and drift velocity. So let us substitute as I1, and let us see two copper wires. Both are of copper, so it means N is same. Both are of copper, so N is same, N same, electronic charge same, A1 and VD1. This is how I've opened I1. Okay, and then I'm opening R1, which is row 1, L1 by A1. Similarly, this can be opened N same, E same, A2, NEA VD2, and then R will be opened as row L by A, row 2, L2 by A2. Okay, so now you can see area is cancelled, area is cancelled, area is cancelled, area is cancelled, N is cancelled, E is cancelled from both the sides, and both are copper. It means resistivity is same. Both wires are of copper, so you can cancel this too. So what are we left with? VD1 and L1 divided equals VD2 and L2. And now you know that L1 was L and L2 was 2L. L is also cancelled, so VD1 by VD2 is calculated as 2 by 1. So ratio is with us. Now let us see question number 22. This question belongs to chapter nuclei, so it's not very hard question, so we can prepare it right now only. We have to tell whether reactions are endothermic or exothermic. So simply masses have been given. Use the information below to answer the question. Okay, that is AMU atomic mass unit. So these are masses. This is a proton, this is of lithium, this is of alpha particle, or you can say helium, this is of neutron, this is of boron. So five masses have been given to us. So simple rule we will use: if the mass of reactants is more than if mass of reactants is more than mass of products, mass of reactant is more than mass of product, then the reaction will be exothermic, otherwise it will be endothermic for vice versa. Now you can see in first reaction there is a proton and there is lithium. Okay, so you can add the masses of proton and lithium. So suppose I add mass of reactants for first reaction. So I will add these two: 1.00728 AMU and 7.0160 AMU. 7.0160, yeah. So you can add them 8 to 10, 7, 6, 13 to 0 and 8. This is AMU mass of reactant. Similarly, you can see mass of product, and in product you should see there are two heliums. Okay, so two helium, or you can say two alpha particle. This is two alpha particles. So alpha plus alpha you have to do. That means mass of products will be two helium is written. So you have to add mass of alpha particle twice. So this plus this. So you can write it as 4.0026 and again 4.0026. So it is coming as 8.0052. So this is less. Mass of product is less than that of reactant. And if it is so, then that means it is exothermic. If mass of reactant is more, because it is 8.02 and this is 8.00, then this is exothermic. Similarly, you can do the second reaction. In second reaction, we have lithium, helium, neutron, and boron, and you have masses are being given to you. So you can do this on your own. Okay, so how many times one atom, one element has been written? You have to add the masses that many times. So that's all. So let us see question number 23. X and Y are two equipotential surfaces separated by a distance of 2 meters in uniform electric field of this. So you can write down the quantities. Distance is 2 meters. Electric field is 10 volt per meter. है ना? Volt upon distance, potential gradient. So yes, it is electric field. Surface X has voltage of 10 volt. We have to find out potential of Y. And what is the work done? Work done is second part that we will see later. Now let us see the question diagram. Yeah, we have been given potential of x surface, so that is given. Potential on surface X, potential on surface Y is to be calculated. Separation between them is given as 2 meter. So it is simple enough. You can do it as electric field is V by D. Okay, यानी कि del V by del D as in voltage upon distance. So let us substitute the value of electric field. Electric field's value was 10. So we can write it as 10. Distance is 2 meters. So we can substitute del D as 2. Now del V को लिखना पड़ेगा हमें Vx minus Vy या Vy minus Vx. Now you should make use of this property of electric field. The electric field is always directed from higher potential to lower potential. So you should know that X is at lower potential. This is at higher potential. So you can see we are making use of theory or knowledge, previous knowledge. Del V को potential difference है. Now whether it is to be written as Vx minus Vy or Vy minus Vx, that has to be taken care of. Now my X is at lower potential, so I will write it as Vy minus Vx, and my separation is 2. So this is Vy minus Vx, and yes, now you can do it. 20 equals Vy minus Vx. And how much is Vx given to you? I think Vx has been given as 10 only. या फिर जो भी given है, so it is 30 volt. So I could calculate potential at surface Y making use of this information. And now let us see the next question, in which we were supposed to find out some work. So let us go through this. What is the work done in moving this charge? So this is Q moved from Y to X along path 1 and then along path 2. तो पहली बात तो path 1 path 2 का वर्क सेम ही रहता है ना, बिकॉज electrostatic force is a conservative force. Conservative force, that means it does not depend upon, it does not, work done does not depend upon nature of path. Work done does not depend upon nature of path. It depends upon initial and final position. तो अगर आप y से x पे आए, किसी भी path से आए, ठीक है, work will be same. So you can write this way. And work by q moved that you should know is v final, यानी कि potential difference लिखा जाता है v final minus v initial. So work can be calculated. आप q moved आपका कितना है ऊपर से देख लीजिए. So q moved is given as 2 coulombs. Okay, and you have come to from y to x. Okay, so you can write it as you have come, this is 2 coulomb. First of all, no micro is not there. You have come to x from y, so it is vx minus vy. 2x from y, so work is 2 into, now vx was 10, I remember, and this was 30. So this is calculated already. It is minus 40. Minus means simply about from where to where. Okay, so yeah, it is minus 40 joules. So important question. This is question number 24. Here it is asked, compare the de Broglie wavelengths associated with electron in the third orbit to the circumference. So you have to remember de Broglie's hypothesis. According to which the circumference of any orbit can accommodate n times wavelength. Okay, n wavelength. Like suppose it is one first shell, so it will accommodate only one wavelength. Suppose it is orbit number 2, so it will accommodate 2 wavelengths. And similarly 3 and 4. So n has to be an integer. So what is that? 2 pi r radius is equal to n lambda. Here they have said third. So n is 3. So 2 pi r equals 3 lambda. This can be left as answer. Or you can tell the ratio. Circumference, this is circumference. 2 wavelength is 3 by 1. Like this also you can report the answer. So question number 1 is this. Now let us see question number 2. In question number 2, they have said, in which of the following will the electrons have same de Broglie wavelength? Will have the same de Broglie wavelength. Same de Broglie wavelength in third, fourth, third, or sixth. Helium, then lithium, beryllium. You can see helium, lithium, beryllium. So let us get to second part of the question is third orbit of helium. So we have to again use that circumference is equal to n lambda. So 2 pi r is equal to n lambda. And now we have to substitute the value of r. Radius we have calculated in chapter atoms. And what is that? that radius is n square h square divided by 4 pi k z e square m, something like this. You should confirm this expression. Okay, so you actually everything gets calculated to 0.53 h 4 pi k e square m, that gets calculated for 0.53 angstrom, and what is left is n square by z, because n and z will vary according to the element. So I'm substituting this value of r here. So let us substitute. So my 2 pi, my expression would be 2 pi 0.53 n square by z is equal to n lambda, and then everything gets into proportionality. 2 is constant, pi is constant, 0.53 is constant. So everything gets into proportionality. Okay, so this comes as, actually this is radius, so I'm rewriting it as radius. So radius and 2 and pi I'm putting into this constant. Radius is proportional to n lambda. So now I am opening the radius again. Everything, this 0.53 I'm putting into proportionality. So n square by z proportional to n lambda. So one n is cancelled. So lambda is proportional to n by z. So you can write lambda is proportional to n by z. Now it was given third orbit of helium. So helium's third orbit. That means n is 3, and for helium atomic number is 2. So my lambda is coming as 3 by 2. Okay, so for first lambda is coming as 3 by 2. Now let us check for second part of the second question. What relation we have got, that lambda is proportional to n by z. So this I will use. Now they have said fourth orbit of helium. Fourth orbit of helium. Again helium is 2, 4. So my z is 2. This atomic number is z. And fourth orbit is 4. Let us substitute here. So my lambda is coming as, proportional to, coming as, it is 4 by 2. So that is 2. Now in the third part, they have given third orbit of lithium atom. Okay, lithium is 3, 7. So you can write as z as atomic number, which is this, n is this. So your lambda will be, which is equal to n by z. N by z equal to a proportionality as you feel. Okay, so it is 1. Similarly, fourth you can calculate. Fourth part is sixth orbit of beryllium. Fourth part is sixth orbit of beryllium. So n is 6. Okay, and you have to remember hydrogen, helium, lithium, beryllium. So beryllium is 4. 5 is boron. So z is 4. So your lambda will come as n by z. So it will be 6 by 4. It will be 3 by 2. So now whose wavelengths are same? Whose answer is 3 by 2? Anyone else? You can see here. Yes, 3 by 2 was first. So third orbit of helium will have same electron, will have same wavelength as sixth orbit of beryllium. So that is the answer. Third orbit of helium atom will have the same wavelength as wavelength of electron in sixth orbit. So wavelength of electron in third orbit of helium is equal to wavelength of electron in sixth orbit of, which was that, it was beryllium. So yeah. So again, what I have used, that circumference can accommodate n times wavelength. Then radius I used as 0.53 n square by z. Can substitute 2 pi 0.53 n square by z equals n lambda. These all I have accommodated in proportionality. So one n is cancelled. So my lambda was coming as n by z in proportionality. So this is how I have done. Question number 25. Using Kirchhoff's law, calculate the current flowing through 4 ohm, 1 ohm, and 2 ohm resistor. Three currents have to be calculated. Flowing through 4 ohm, 1 ohm, and 2 ohms. So you can complete the diagram. We can take current from positive of cell. This is 10 volt. I am taking current I1 from this. And yeah, you can complete the circuit diagram then. I1 will flow through this also. I1 will reach here. And similarly, some part of current will go through this. From I1, I2 is going through this. Okay, I2 is reaching this. I2 is coming here. And remaining current, which was I1 minus I2, will go through 2 ohm. So you have to see the diagram once again. See, I have taken from this I1, you can say I1. I1 will go through this 4 ohm and I1 has reached here. Now from the 1 ohm, because here bifurcation is there, two branches are there. So I2 I am taking from this, and from this 2 ohm, the middle one, remaining current, which is I1 minus I2, will go. Okay, they will come here, meet at S, I1 minus I2, and I2 will meet at S. So I1 will re-enter. So this is correct. Now you can make equations in half loop. Let us make equation from this left half. So let us see. Okay, I'm starting from here. PQ and S. This is P, Q, S, P. So when we go from P to Q, my resistance is 4 and current is I1. And then when I'm going from Q to S, what is my resistance? This 2 ohm. And current is this. So positive 2 into I1 minus I2. And when I'm going from S to P, I'm hitting against negative. So minus 10 equals 0. This is my first equation. You can open the bracket. 4I1 plus 2I1 minus 2I2 minus 10 equals 0. So I1 I can add. This is 6I1 minus 2I2 minus 10 बराबर में 0. This is my first equation. I can rewrite it. 6I1 minus 2I2 minus 10 equals 0. If I wish, I can take 2 common. If 2 common, then 2 will go to 0. 3I1 minus I2. 2 5s are 10. So 2 I have taken common. Okay, if you wish to, you can write 2 this way and then 2 will go that side. So 3I1 minus I2 minus 5 equals 0. Now let us see the right half. Now you can write the loop as Q, R, S, Q. So when I go from Q to R, resistance is this, current is this. So it is I2. And when I go from R to S, I'm hitting against negative terminal. So minus 6. Then S to Q, my current is opposite because I'm going from S to Q. So minus resistance is this 2. And then current is this. So I've written the voltage. Current into resistance is voltage. Kirchhoff's second law. So every term of this equation is a voltage. This was resistance was 1, current was I2. So this is a voltage. 6 volt is a voltage. Then 2 is resistance. This is current. Again, it is a voltage. Sum of voltages in a loop is 0. So this is my second equation. Let us open it. Minus is there, so sign will be changed. Now add the like terms, add or subtract. So this is 3I2. First is minus 2I1, then 3I2, then minus 6 equals 0. You can rewrite this equation. Here it's minus 2I1 plus 3I2 minus 6 equals 0. Now you can see I'm ready with 1 and 2 equation. My first equation is containing I2 and this is containing 3I2. So I am multiplying my first equation by 3. And I'm writing here 3 into 3, 9I1. Then minus 3I2, then 3 into 5 is 15 equals 0. Now you should see what should you do. To cancel out I2, you should add or you should subtract. You should add because there are opposite signs, so add them. This will be cancelled. You will be doing this. 9 minus 2 is 7I1, and 15 and 6 is minus 21 equals 0. So 7I1 equals 21 and I1 equals 3. So my first current is ready. Now what is I1? Go to the diagram and see what is I1. So I1 is 3 and I1 is the current through 4 ohms. So I am ready with one current at least. Now I'll substitute I1 and find out I2. My I1 is this. I'll put in first equation, which is this equation. 3I1 minus I2 minus 5 equals 0. Using equation 1, 3I1 minus I2 minus 5 equals 0. You can substitute here I1. In these questions, generally not always currents are substituted with sign. Abhi to by chance I1 is positive, so no difference. But if it comes negative, I have to take sign. So minus 5 equals 0. So it is 9 minus I2 minus 5 equals 0. So 9 minus 5 is 4. And whose sign will come? 9 sign will come. So minus I2 equals minus 4. So I2 equals 4. So my first current was I1, which is 5 ampere. Is it 5 ampere? Sorry, 3 ampere. And then I2 is 4 ampere. And my third current is I1 minus I2 in the third branch. So it is minus 1 ampere. 3 minus 4. 3 minus 4 is minus 1 ampere. So you can see currents have to be taken with sign. So how will you write the answer? Current through, there are 3 resistors, no. Current through 4 ohm equals dash. Current through, there was 1 ohm equals dash. Now you go through diagram and see. 4 ohm, then we have 1 ohm, and then we have 2 ohms. 1 ohm is I2. 1 ohm, then current through 2 ohms. 4 ampere था I1, so I1 is 3 ampere. 4 ohm वाला 4 ohm में से कौन सा करंट था I1, so that is 3 ampere. 1 ohm में से करंट था I2, which is 4 ampere, and इसमें I1 minus I2 था तो minus 1 ampere. Minus simply डायरेक्शन दिखा रहा है कि ऐसी डायरेक्शन लेनी चाहिए थी, but it is okay. So we are ready with answers. This is question number 26. Two charges A and B. Two charges A and B. So charge A and charge B, you can write it as Q1. Velocity is V, each having velocity V. The charge is different, but velocity is same. Traverse circular path and uniform electric field, so magnetic field is also same. So you have to pick up these quantities from the statement. Okay, nothing is written in the statement, but still so many quantities. Magnetic field is same, velocity is same, charges are different. Okay, compare the charge to mass ratio of the two particles A and B. Show the necessary mathematical calculations. So you should know that this question belongs to chapter 4. In that, centripetal force used to be provided by the magnetic force, and magnetic force is here QVB. Centripetal force is mv square by r. So 1v will be cancelled, and my radius will be radius mv by qb. This is not a part of solution, just I needed the formula for radius. If you remember it, you can write it directly. So no marks will be given for this portion. So my radius formula is radius mv by qb. Now I will write it for first, this which is 1, 1, 1, 1 and 1. Similarly, I will write it for 2, m2v2 divided by q2v2, and now I will divide. So radius 1 divided by radius 2 is, so radius 1 will be written as it is, and radius 2 will be inverted, reciprocated. Now you can see velocity is same, v1 equals v and v2 was also equal to v. So v will be cancelled, and magnetic field was also same. B1 was uniform. They are kept in same magnetic field, so it is cancelled. Now what are we left with? R1 by R2 equals M1 by Q1. into Q2 by M2. So now you should see the diagram. Whose radius is more? Radius of B is more, as in 2 is more. Okay, radius of A is less and radius of B is more. So R2 is more than R1. So I will use that fact that R2 is greater than R1. So what is my R1 by R2? R2 I will bring this side. So R1 by R2 is less than 1. So this less than sign is coming towards this. So this quantity is less than 1. So you should write that. Okay, so R1 by R2 की value कितनी है? This is the value. Let us substitute M1 by Q1 and then Q2 by M2 less than का sign towards it and then 1. इसको पलट के लिख लो because it is little comfortable for me. M1 by Q1 then Q2 by M2 less than का sign towards it and then 1. Now what have they asked? They have asked charge to mass ratio. Charge to mass. So how will it be written? This is charge to mass of second है ना, तो you can write Q by M of second यानी कि B and then this is Q by M नीचे है ना, तो उल्टा हो गया वो Q by M of first as in A. ये कितना आ रहा है? लेस देन 1. सो हो गया कंपैरिजन. इसको आप उधर लेके चले जाइए. सो चार्ज बाय मास रेशियो ऑफ B is less than charge by mass ratio of A. So this is how I have compared. You can do the practice of this question number of times. Now let us see the second part of the question, which is which of the two particles is likely to be a proton if the other is alpha. So which is proton and which is alpha, they are asking. That is, if A is proton or B is proton, that is what they want to ask. So let us see proton and alpha. So we are needing proton and alpha at every other question. So alpha is written as helium-24 and proton is, you should know, 1H1. Okay. So you can pick here charge of alpha as 2e, charge of proton as 1e, mass of alpha as 4 mp and mass of proton as mass of proton. And Q by M निकाल लीजिए. Q alpha by M alpha, it's 2e by 4 mp. And similarly QP by MP, which is 1e by 1 mp, that is E by mp. तो आपको दिख रहा होगा 2 and 4 will be cancelled, यानी कि Q alpha by M alpha can be written as half E by mp. और ये क्या है? E by mp is your this. तो charge by mass of alpha is half times charge by mass of proton. तो अल्फा का आधा है. अल्फा इज लेस. Q by M of अल्फा इज लेस. तो यहाँ पे किसका लेस आया है? Q by M of B इज लेस. Q by M of B लेस है. और यहाँ से भी आपको दिख रहा है Q by M किसका लेस है? अल्फा का, है ना. अल्फा का आधा है प्रोटोन से. प्रोटोन का यानी कि डबल है. तो इट मीन्स B इज अल्फा एंड A इज प्रोटोन. अगर ऐसे लिखा है Q by M of alpha is half of Q by M of proton, इसका मतलब अल्फा का आधा है. आधा यानी कि कम. Let's see question number 27. A radio wave. So one is radio wave, another is infrasonic wave. They have same wavelength, so lambda 1 is lambda and lambda 2 is also lambda. When traveling through air, are their frequencies same or different? Give a reason for your answer. So radio wave is a light wave. Light wave as an electromagnetic wave. You should write radio wave is electromagnetic wave. Infrasonic wave is sound wave. Radio wave is electromagnetic wave and infrasonic wave is a sound wave. So their velocities are different. So you should write their velocities, their speeds. through air is different. Okay, and you know velocity equals lambda into frequency. Velocity is different, wavelength is different, so their frequency will also be different. Sorry, a wavelength is same. Wavelength is same. Yes, wavelength is same. Velocity is different. Wavelength by chance they have given same, so frequency will be different. Frequency will be different. You can simply write this. If you wish, you can write this way, lambda into f1. And here velocity is v2, lambda is lambda, wavelength is same. So frequency is v1 by lambda here. And here frequency is v2, speed is different by lambda. So you can write different. Frequencies will be different. Now let us see the next part of the question. An electromagnetic wave traveling east has a magnetic field that oscillates vertically and has a frequency of this much, an RMS strength of this much. Magnetic field किया. Determine the frequency and RMS strength of electric field. What is the direction of electric field? So wave is traveling east, magnetic field is vertical. Wave is traveling east, vertical, magnetic field is vertical, frequency is 60 kilohertz. So let us write down. Wave is traveling east, east is this way. So this is EM wave. This is the direction of propagation of EM wave. And vertical is magnetic field. This is magnetic field oscillation. If you remember, we draw such a diagram. This is magnetic field. So of course, x-axis is taken by EM wave, y-axis is taken by magnetic field. So what is left for electric field? So electric field is along z. So you can write electric field. Electric field vector will be along z-axis. Okay, so z-axis is this way. You can write along z-axis. That's all. उसके बाद we have been given frequency of magnetic field was given as 60 kilohertz, which is 60 into 1000 hertz if required. And then RMS value of magnetic field was given as 8 into, or it was given as, let us see what, 8 into 10 to the power minus 9 Tesla. So yeah, RMS value of magnetic field is given as 8 into 10 to the power minus 9 Tesla. We are asked the frequency of electric field, so frequency will be same. Okay, sine omega t is sine omega t for both, whether it is for electric field, whether it is for magnetic field. So you can write frequency is same. So frequency for electric field will also be 60 kilohertz. So one answer will be for this. And now you have to find out RMS value of electric field. So that relation you should be knowing, that E by B is C. If you know this, you can find out. If it is RMS, you can write RMS. So electric field's RMS value will be C, which is 3 into 10 to the power 8 times B RMS, and B RMS has been given as 8 into 10 to the power minus 9. So this is your electric field, but you should write it with unit. 8 into 3 is 24, and minus 9 plus 8 is 10 to the power minus 1. You should write unit. Unit is, there are so many units for electric field, but this is V by D के हिसाब से volt per meter or Newton per coulomb according to F by Q. Electric field's formula is F by Q also and V by M also. So you can write the unit from anywhere. So this is how it will be done. Question number 28. A circular ring of diameter. This is diameter, so you can find out radius. This is magnetic field. The ring is rotated about its diameter. Rotated about diameter at a frequency of this. This is nu. If it has this much turn, this is capital N. So diameter is there. You can find out radius. And then magnetic field, then nu, frequency. What is the maximum induced EMF? So E max, if you remember, E naught or E max, it used to be NBA omega. And then sine omega t is E की equation. So what comes sine omega t से पहले is E naught. So N B, area is pi r square and omega can be written as 2 pi nu. So N you have 50, magnetic field you have in Tesla, area is pi r square, radius can be diameter ka half, and then 2 you know, pi you know, and nu is directly given. You can find out maximum EMF, but again it should be reported in volts. And then you have to tell state one condition under which the induced EMF in the circular ring will be 0. So this is important. Under what we have to write one condition under which the EMF in the circular ring will be 0. So actually for ring, magnetic field is this way. You know, if current is flowing, yeah, using right and thumb rule, this is a magnetic field, right? Use right and thumb rule. Keep your curls along the ring, along the motion of the current, and your thumb will point out this way. So this is magnetic field. So abhi you were rotating the ring along the diameter. Okay, diameter ऐसे so many diameters are there. Okay, whichever way you were rotating. But if you rotate along this axis only, along the axis which is passing through its center and perpendicular is plane, okay, then magnetic field, then EMF will be 0. So you can write if the ring is rotated about its axis. If ring is rotated about its axis. Abhi to it was rotated about its diameter, so we got that answer first part. And for EMF to be 0, the ring should be rotated about its axis. Now let us get to second part of the question. This is or part of the question. Given below are few characteristics. Given below few characteristics of solenoid P and Q. Length of solenoid is same 1 meter 1 meter. Number of turns is more here. Area is same. Relative permeability of material is mu r. Relative permeability is mu r, which is 1 in the first case, that is air is there, and 500 in second case. Self inductance is this. You have to find out the self inductance in the second case. Okay, let us write the formula for self inductance for P. It's mu r into mu naught into mu n square a by L. If some material is there, mu r also comes. So how much is LP? It is 2 millihenry. Okay, don't look at this question. This is some other. 2 millihenries are 2 into 10 to the power minus 3. Mu r is how much? It is 1. Mu naught ko mu naught. N square. N number of turns for P is 200. So it is 200 square. Area is A. Length is 1. Yeah, 1 or L something. So L you can write. Leave it as L because it is same. So you are ready with 2 into 10 to the power minus 3 equals mu naught. 200 into 200 and then A by L. So please be ready with mu naught A by L. You can take 2 into 10 to the power minus 3 this side and this will go downwards. 200 into 200. This we are ready with. Okay, now we have to find out the self-inductance of Q, which will be written as again mu R into mu naught because some material is there inside Q. N square A by L. Mu R and then this mu naught n square also आगे A by L. We are ready with mu naught A by L, which is this. So you can substitute mu r as it is, n into n as it is, and this is 2 into 10 to the power minus 3 upon 200 upon 200. And now you can check for mu r. Mu r here it is given. It is relative permeability of core material is 500 and number of turns is 50. You can substitute and report the answer. This is 50. No, this is 200. Again, we'll have to see. It is 500. Mu r is 500 and n is 50. So you can substitute mu r as 500 and n is 50 into 50. And now you can solve it properly and report the answer. Do not forget to add the unit. It is Henry. Self-inductance of Q you can report this way. Let us see question number 30. Question number 29 was also a case-based question, but that belonged to chapter semiconductor, which we haven't done so far. So let's see this. When light rays fall on glass, about 4% of the light gets reflected. To eliminate this reflection, the glass display cases in museums usually have an anti-reflective coating. This works on the principle of interference, so you can learn the use of interference, application of interference from here. That the concept of interference is used in providing anti-reflective coating to reduce reflection. When light falls on coated glass, the light gets reflected from top and bottom surfaces, and these two reflected light rays can interfere. To reduce reflection, the thickness and refractive index of the coating are adjusted such that the light rays undergo destructive interference. Okay, so you can see here it is coating. This is air. This is coating with N2, and this is glass with N3. This is glass. So this is ray reflected from the first part. This is ray reflected from the second part. Okay, so this is how it is. And thickness of the coating is given as T. So reflected light undergoes 180-degree phase difference when it falls on a denser from rarer. From rarer to denser, 180-degree phase difference, and no phase shift when falls on rarer from a denser. Denser to rarer, no phase difference. So thickness is given as T, and this is the situation. N3 is maximum, N2 is greater than N1. So N1 is least, which is air, and N3, which is glass, is maximum, and then N2 is your coating, anti-reflective coating. So first question is which of the following occurs? Which of the following occurs if there is no coating on glass? अगर coating नहीं होगा तो क्या होगा? They told already. Why are we doing coating? To reduce reflection. So what will happen if there is no coating? Reflection will occur. So first, second, third. Third is okay. A reflection of object is seen. So reflection will occur if there is no anti-reflective coating. So this is the correct answer. Now let us see the next part. What is the part difference between ray 1 and ray 2? So ray 1 you saw was the one which was reflected from the top. This was ray 1, and ray 2 was coming from here, following laws of refraction. This was ray 2. So ray 1 was which was reflected from here only, and ray 2 traveled and then came back. Okay, so when it travels T, and then when it comes back, it travels T once more. So basically it is 2T. So 2T is the part difference. T in going, and then T is in coming back. So 2T is the part difference. You can go for option 2T. Then let us see part 3. For what minimum thickness of the coating? For what minimum thickness of the coating do rays 1 and ray 2 undergo destructive interference? So you have to recall destructive interference case also. So for destructive interference, part difference should be interference wala. For dark fringes, it is 2n minus 1 lambda by 2. It is part difference, no? So no D and D will come. पार्ट डिफरेंस में दोनों डी नहीं आते. सो पार्ट डिफरेंस अभी कितना बताया था? अंदर जाने में टी एंड बाहर जाने में टी. सो इट वाज 2t, एंड प्रॉपर पार्ट डिफरेंस इज रिपोर्टेड व्हेन यू इंक्लूड द रिफ्रैक्टिव इंडेक्स. तो रिफ्रैक्टिव इंडेक्स कोटिंग का कितना था? n2. ओके, सो दैट इज कॉन्सेप्ट ऑफ ऑप्टिकल पार्ट डिफरेंस. ऑप्टिकल पार्ट डिफरेंस में आपका रिफ्रैक्टिव इंडेक्स भी इंक्लूड होता है. हाँ, तो टी अंदर जाने में, टी बाहर आने में, सो इट इज 2t, एंड देन यू हैव टू मल्टीप्लाई विद रिफ्रैक्टिव इंडेक्स, एंड देन इसका मिनिमम वैल्यू रखना है तो आप इसको 1 रखिए, n को. 2 into 1 is 2, minus 1 is 1, so it is lambda by 2. So your t is thickness पूछा है, तो your thickness is lambda by 2, and then 2, and then n2, so it is lambda by 4 n2. Again we have picked up the dark fringe formula, destructive interference formula. पार्ट डिफरेंस ओनली. पार्ट डिफरेंस में दोनों डी नहीं आते, कैपिटल डी एंड स्मॉल डी. तो पार्ट डिफरेंस इज दिस मच. मिनिमम वैल्यू के लिए आप एन को 1 लेके चलिए, एन की वैल्यू 1 डालें. अगेन पार्ट डिफरेंस जो मैंने यहाँ लिखा है लेफ्ट में, वो टी अंदर जाने का एंड टी वापस आने का. एंड ऑप्टिकल पार्ट डिफरेंस इंक्लूड्स n2 ऑल्सो. थोड़ा सा एडिशनल इन्फॉर्मेशन है ये, तो केस बेस थोड़ा सा हाई लेवल का दे रखा था, तो एडिशनल इन्फॉर्मेशन इज नीडेड फ्रॉम हायर क्लासेस। तो पार्ट डिफरेंस में आपको रिफ्रैक्टिव इंडेक्स भी इंक्लूड करना पड़ेगा। ओके, दिस एन इज नंबर ऑफ फ्रिंज वाला and this n is refractive index. So n2 will go that side, 2 will go that side, or t can be calculated. Now let us see the next part. Yeah, let us see this. This is or part. For what minimum thickness? Again minimum है तो n will be 1. Do the rays 1 and 2 undergo constructive? Constructive मतलब dark bright interference. So for that part difference is n lambda. If you remember from interference, part difference अभी कितना बताया था? t जाने का t आने का, तो 2t, and then optical, proper optical part difference के लिए you'll have to include the refractive index also of the anti-reflective coating, or n should be 1, so it is 1, and then t will be lambda by 2 and 2. So go for that. Fourth part, fourth MCQ. If the material of coating is changed so that n2 is greater, then what will be the additional part difference? So एक बार हम देखेंगे आपकी जो कोटिंग लगा रखी थी, ओके, ऊपर एयर था, देन इट वाज n2, देन इट वाज n3. अभी जो इनिशियली सिचुएशन थी, n1 वाज लीस्ट, देन n2, देन n3. दिस इज कोटिंग, मिडिल वाला ये ग्लास था, ये कोटिंग था. Initially what was happening, and now what is the question? Initially what was happening when you were throwing light, then here, because you are entering from rarer to denser, so part difference was taking place of pi, that is given in the question, that when the ray goes from rarer to denser, 180-degree part difference takes place. Okay, phase difference takes place, and then again you are entering from n2 to n3, that is again from rarer to denser, है ना. इन दोनों का कंपैरिजन देखेंगे. So one more, pi and pi is 360 degree means no path change. Earlier that was the difference, that was the case. But now they are saying that n1 is n1, air is air, now n2, and then n3. Now they say it is the densest. So it means when the ray is coming from rarer to denser, okay, pi ka difference. But when ray is going from denser to rarer, no difference. So how much is the total phase difference? Pi only. Earlier it was 0, now it is pi. And pi के लिए, 2 pi के लिए you have the part difference of lambda. Full चक्कर के लिए wavelength. So pi के लिए it is lambda by 2. Okay, let us see it once again. Earlier, I'm not talking about part 4. What was the original situation that they were telling? And that has nothing to do with any of the questions that I'm just telling. Air was given, and then your anti-reflective coating, and then glass. Earlier it was a situation, okay, and it was the densest, and then this was the rarest. So n1 was least, n2, and then n3. So when ray is coming from 1 to 2, it is coming from rarer to denser, so pi ka phase difference. Then again when n2 to n3, again pi ka difference 180 degree, and then फिर 180 degree यानी कि 360 degree. It means no change. So in the beginning no change was taking place. But now they are saying in a situation, then n1 and then n2 and then n3. Now they say it is the densest. N2 is maximum, then n3, then n1. So compare n1 and n2. So n2 is greater, so it is r to d, pi ka difference. But when you are going from n2 to n3, you are going from denser to rarer, so no difference. So what is the total phase difference? Pi only. Pi के लिए what is the part difference? So 2 pi के लिए part difference is lambda, full length. 360 degree के लिए full length, wavelength. So 180 degree के लिए it is lambda by 2. So lambda by 2 is the answer. So let us see question number 31. A ray of light is incident at an angle theta. This is theta. You can see here it is theta on a right angled prism at point X. So this is right angled prism. So you should note the angle of prism is 90 degree. This is angle of prism. Yeah, refractive angle of prism. Okay, this has been given as 90 degree right angled prism it is. At point Y, it emerges along the prism surface. So you can see the rays emerging along the surface. It means it is falling at critical angle. At critical angle only, the ray grazes the surface. It is not gone out. It is coming along the surface. It means angle of incidence is equal to critical angle. This is IC. This is critical angle. So in the figure, it is a right angled prism. So this angle is 90 degree. This angle is 90 degree. It is to be noted as A equals 90 degree. And you see this ray is falling at this face of prism and it is not able to go out. It is grazing along the surface. It means it is falling at an angle of at critical angle. So this is normal and this is critical angle. If it will fall at an angle more than critical angle, then it will be reflected inside, which is not happening right now. Right now it is falling at critical angle. So you can complete the triangle using these normals. Here what do we label? If you remember, this is R1 and this is R2. But right now R2 is critical angle because critical angle is the angle in the denser medium for which angle of refraction is 90 degree. Angle of refraction is 90 degree. So yeah, this is R2 and this is equal to critical angle. Very important. And now let us use the concept. First of all, because incident ray, okay, and this is normal. Here it is written theta. This is angle of incidence. Then this is the ray and it is going this way. I already told you because the ray is trying to go from glass to air, that is denser to rarer. This is one condition. And second condition, it is falling at critical angle. Then only it is grazing along the surface. So you can complete the triangle. This is R1. We take it R1. We take this as R2, but right now R2 is IC, critical angle. And this is 90 degree. This is also 90 degree because angle is, prism is right angled prism. So from the triangle R1 plus IC plus 90, you can write it as R1 plus IC plus 90 as 180 degree. R1 plus IC as 90 degree, 180 minus 90. So IC is ready as, or you can say R1 is ready as 90 minus IC. R1 is ready as 90 minus IC. Now, because I would be needing sine R1, so you can take it sine on both sides, 90 minus IC. Sine of 90 minus IC is cos IC. So this is my sine R1. And cos I should write in form of sine. So cos theta is written as 1 minus sine square theta. So this is how I have written sine R1. And you should know when TIR is occurring, or you can say the relation for TIR is mu equals 1 by sine IC. You should go through the topic so that you know this formula. So sine IC can be written as 1 by mu, which I am going to substitute here. So let us substitute. So my sine R1 is ready as root 1 minus sine square IC it was. So it is 1 by mu. This is sine IC square. Now you can please simplify it further. Sine R1 can be written as 1 minus 1 by mu square, which can be written as, take LCM, mu square minus 1. So mu square will come out. So it is mu square will come out as in out of the square. So its square will be cancelled. Out of the square root, square will be cancelled. So it will be mu, and upside it is mu square minus 1. So this is my sine R1. Now I will use Snell's law at the entering phase. So you can go to the the prism. Here where it is entering, this is angle of incidence and this is angle of refraction. I will use Snell's law. So Snell's law I will use, using Snell's law, sin I by sin R equals, where are you entering glass? From air. Mu air is 1, mu glass is mu. Mu is to be calculated, okay? So angle of incidence given as theta, and sine r is r1, it is mu. So my sine theta, and what is my sine r1? I have just calculated. You can see sine r1 is this, root upon mu. So it is root, and mu will go up. It will be written ulta, you can say. And now from both the sides you can cancel this mu. So what are you left with? Sine theta equals sine theta by this term mu square minus 1 within the root equals 1. So sine theta is mu square minus 1. You can squaring both the sides. Otherwise also it is okay. Squaring both the sides. So when you square, it is sine square theta. And here the square root will be cancelled. So your mu square is minus 1 will come this side. 1 plus sine square theta. And mu will be root of 1 plus sine square theta. So this is the relation. Mu is calculated this way. So we need to go through total internal reflection for this topic to be understood, for this question to be understood. So yes, the topic that it covers is very important, TIR. How did I come to know that it is a question related to TIR? Because here the surface, the ray was grazing the surface. It is incident ray and it is grazing the surface. So the angle of incident is critical angle. Angle of refraction is 90 degree. When such is the situation, then sine I by sine R is, where are you going? To air. So mu air up. Where are you going from? Mu glass. So sine IC, R is 90, sine 90 is equal to mu air, which is 1, and this is mu. So sine 90 is 1. So our relation is sine IC by 1 equals 1 by mu. This is not related to question. I'm just telling you that this is TIR. Please prepare. This is the formula that we have used here. And from the figure itself, we knew the okay TIR is happening here. So let us see the second part of the question. And you should see one more thing from here, that in paper, both parts of the 5 marks question are, conceptual, numerical based. First part was this, and second part is this, which is also conceptual or numerical, you can say. No theory. Theory is required to do every question though. Show that for equilateral prism. Earlier it was right angled, so when it was right angled, I told you that angle of prism is 90 degree. And now it is equilateral, so angle of prism will be 60 degree. Minimum deviation occurs with this. This is to be proved. N is refractive index. So you can make that prism if you want. Angle of prism will be 60 degree because it is equilateral prism. Okay, and you can do the question. What is to be proved? To prove is I equals sine inverse n by 2, something like that. So I is to be calculated. So you can use prism formula. Using prism formula, you should prepare prism formula. What is prism formula? Prism formula is sine I by sine r, or you can rewrite as sine. If you know prism formula, it is a plus del min by 2 divided by sine a by 2 is equal to mu. This is prism formula. This is prism formula. But right now, because I need I, so numerator I will keep as this, but denominator I will keep as this. And then right hand side this. So I will rewrite it as sine I, because I is to be calculated. Denominator I picked up from prism formula. And then this is mu. Mu is n. They say refractive index is n. And now what is A? Already told you A is 60. So what is sine 60 by 2? It is sine 30. And what is the value of sine 30? It is half. So let us do this. Sine I up, sine 30 down. So it is 1 by 2 equals n. So sine I 1 by 2, 2 will go up, equals n. So sine I 2 will go that side, n by 2. And now I will be left alone, which is the question sine inverse n by 2. So you can see in 5 mark question, both are numerical or conceptual. So you'll have to do a lot of practice. Now let us see the next question. Yes, this is the question. A Young's double slit setup is illuminated with monochromatic light. If the intensity of light passing through one of the slit is reduced, explain the changes that can be seen in appearance of bright and dark fringes. So in Young's double slit experiment, what happens? Generally, we take both the intensities equal. I1 is I and I2 is also I or I naught. Okay, so in that situation, what happens? Generally, both the intensities are equal coming out of the two slits. So I max is how much? If you remember, I max is your root I1 plus root I2 ka square. Please prepare chapter wave optics. And I min is root I1 minus root I2 ka whole square. Now both are equal, I naught and I naught. So it is 0. And here you can like put anything like let it be I naught plus I naught ka square, which is equal to 2 root I naught ka square, which is equal to 2 ka square is 4, and this is I naught. If it is ordinary Young's double slit experiment, intensity of both the slits are equal, and I max bright fringe intensity is this much, minimum intensity is dark. Dark is completely dark. But now if intensity is reduced, intensity of anyone is reduced, okay, then what happens? Like I've taken this value. If it is reduced, then bright will be less bright. Bright fringe will become less bright. Become less bright. You can write like this. And dark fringe, which was earlier completely dark, will be less dark now. मतलब कुछ brightness होगी. Will be less dark. So this is the difference. Now let us see the next part of the question. Uh, single slit diffraction setup is illuminated with green light of wavelength this much. So wavelength is 500 nanometer, 500 into 10 to the power minus 9 meter. If the width of the slit, A is a symbol I denoted with 1 mm, so it is 1 into 10 to the power minus 3 meter. Screen distance is capital D, it is 2 meter. Calculate the width of the central maximum. So width of the central maximum in diffraction, all of you please remember this. In diffraction, width of the central maximum is twice of ordinary fringe width. So it is twice of ordinary fringe width in case of diffraction. So fringe width of central maximum, first of all, where in diffraction only. In diffraction, it is twice of ordinary fringe width. And what is ordinary fringe width? Lambda d by A here. So 2 is given, lambda is given, d is given. You can find out the fringe width, report in meters. Then coming to the next part of the question. Okay, B का भी दो तीन parts है. What will happen to the width of central maximum if green light is replaced with red light? Green is replaced with red light. Green, earlier it was green and now it is red. And what is the formula of beta fringe width of central maximum? Beta of central maximum is twice lambda d by d. So you can see lambda d by d or A as you feel comfortable. So beta is fringe width is directly proportional to wavelength. And whose wavelength is more? Red's wavelength is more than green. So fringe width will increase. If you are replacing green with red, so wavelength is getting increased as wavelength of red light is maximum. Yeah, more. Wavelength of red color is more, so fringe width of central maximum will increase. Fringe width of central maximum will increase. Now let us get to the next part of the question. So you can see in or part they have asked 4 questions. A student wishes to study diffraction of sound using single slit. He replaces the light source with a sound source, of course. What other change he should do? So wavelength of sound is much higher, is greater than wavelength of sound is much greater than that of light. Wavelength of sound is greater than light. So what changes should he do? What change should he do? First of all, the fringe width, slit width, sorry, slit width should be increased because wavelength of sound is higher. Wavelength of light was lower, so earlier we have kept the narrow slit, and now slit width should be increased. First change is this: slit width should be increased. And what change? Earlier you were using a screen है ना, to observe dark and bright fringes, and now you should use a sound detector. So screen should be replaced with a sound detector. Screen should be replaced with sound detector, and slit opening should be increased because wavelength of sound is higher than that of light. Question number 32. A camera usually operates at 1.5 volt, and this potential difference is not sufficient to emit light energy using flash. For this purpose, a flash circuit of camera has a capacitor that is charged to this much volt using various electrical components. If the voltage generated across the plates of capacitor is this much, so this is the voltage that we are going to use, and the capacitance of parallel plate capacitor is this. So you can see capacitor's voltage is this. Though so many voltages have been mentioned, this is mentioned, this range is mentioned, but the voltage across the capacitor is this, so we'll use this. And capacitance is this, 100 microfarad. Find the energy release. One question is this: find the energy. So you can use half CV square. You can calculate how much charge does this capacitor, so this is C, this is V, so charge is CV. You can find energy. You should report in joules, charge in coulombs. If the distance between parallel plate capacitor is parallel plate capacitor of capacitance this is increased 2 times, then what will be the capacitance? So earlier capacitance is given 100 microfarad, and now the distance is increased twice. So you can do it. Like capacitance, original capacitance is given as this. And how is this opened? This is opened as epsilon naught A by D. So this has been given. You have been asked when the new capacitance, when the distance is doubled. So you can use it this way. This is half into epsilon naught A by D. So half times C original. Half time means half of 100. So this is 50 microfarad. If the distance is doubled between the plates of the capacitance gets halved. So let's see the next part of the question. So you can see in 5 marks how many questions they have put up here. Energy release, but it is easy. Then charge, and then distances effect. 3 question this, and then there is C part. In that they have given this Q versus V. And what have they asked? Which of the two lines A or B correspond to scenario Q? What is Q scenario? The space between the capacitor is filled with substance of dielectric constant K. And scenario P, the space is filled with air. So scenario P is capacitance with air, and scenario Q is capacitance with dielectric substance of dielectric constant K. So you should know when the space is filled with the substance. So in that case, capacitance is K times. And when it is filled with air, then it is C naught only. So it means capacitor is more in Q. In case Q, capacitance is more. So we have to find out which one of A or B corresponds to Q. So we should write this thing that capacitance in Q is C times this. So capacitance in case Q is more because it is K times. And now you should see the graph. There were 2 graphs. Let us see what are they plotted against Q and V, and then A and B. So you should talk about the slope. Slope is Q by V, perpendicular by base, and Q is CV, VV cancelled. So slope is giving you capacitance. So whose slope is more? A slope is more. So slope of A is more than slope of B, and slope is giving you capacitance. So capacitance of A is more than capacitance of B. So A corresponds to Q scenario in which the space between the capacitor is filled with dielectric. So Q scenario is represented by curve A. Let us get to the next question now. So in the diagram you can see one hand of C1 and one hand of C3. They are together, and similarly other hand of C1 and the second hand of C3 are also together. So they are in parallel. They are connected between same 2 points. So you can make the diagram C1 and C3. They are in parallel. Okay, so this portion I have drawn. Then this joint hand is connected to C2. This is C2. And then there is P, and then there is Q, and then in lower portion we have C4. So this is how the diagram is. C4 is this way. This is C1, C3, C2 and C4. So you have to draw this diagram. Okay, once it is ready, each capacitor is of 6 microfarad. So now because C1 and C3 are in parallel, so you can solve for them. Okay, so I'm solving for C1 and C3. C1 and C3 are in parallel. So which formula is used in parallel? You should know. It's Cp equals C1 plus C3. So it is 6 plus 6, 12 microfarad. I hope it was 6. Yes, 6. So it is 12. So the answer of C1 and C3 is 12. So the answer of C1 and C3 is 12. So you can remove these both and you can make Cp. So I will make here. So in place of, see what was the diagram right now? It was P and Q, then it was C2, then in parallel they were connected. Yeah, parallel C3 and C1 were connected, and then it was C4. And now that I have found the answer of C1 and C3, I will replace these both by that Cp. So rest of the diagram will remain as it is. This is P, this is Q. So this is C2. And now answer of C1 and C3 is to be connected here, which is Cp. And then we have C4 as it is. So this is 6, this is 12, and this is 6. Now C2 and Cp are in series. So C2 and Cp are in series. So you can find out C series for them. So C series will be just C1 C2 divided by C1 plus C2. यानी कि C2 Cp divided by C2 plus Cp. Let us substitute. It is 6 into 12 upon 6 plus 12. So it is 6 into 12 by 18. So it is 4 microfarad. So you should see C series is coming to be 4 microfarad. So in place of these both, I am going to draw that C series. So my next diagram will be P and Q as it is. In place of C2 and C parallel, I will write this was C2 and this was C parallel. This was C4. And in place of these both, I am drawing C series because they were in series. So this was P, this was Q, and this is C series, which is coming to be 4. And then C4 was in parallel. C4 is 6. And now you can see C series and C4 are in parallel once again. So my net capacitance is ready now because they are in parallel. So it is C4 plus C series. So it came as 6 plus 4. It is 10 microfarad. So this is net capacitance is 10 microfarad. This is one answer. So to do the second part of the question, which is to find the ratio of charges on C1 and C4, potential difference is given as 10 volt. You should draw all the diagrams which you have come across while solving the question. Like my first diagram was P and Q, and then I have drawn C2, then they were in parallel. C1 and C3 were in parallel, and then lower portion it was C4. You have to draw, or you should draw all the diagrams at one place. So now you can see C1 and C3 were in parallel, so we did it like this. Diagram number 3, C2 as it is, and they were in parallel, so one answer came, which was CP, and it was the diagram C4. Now C2 and CP were in series, so we can draw that. P and Q as it is, they were in series, so C series came, and lower was C4. Then they were in parallel, so C net came. This was C net and P and Q. So there were 4 diagrams which I've drawn with red color. There were 4 diagrams. Now let us see how to do it. Voltage, they have told us 10 volts, so you can write V net. This is V net. On every capacitor, you should write the voltages and charges. C net came as 10 microfarad. So you can find out Q net. Third quantity is missing. Q equals CV, net, net, and net. So it is 10 into 10, it is 100 microcoulomb. Now see, this is fourth diagram. Now go to the third diagram. What is this? If you remember, this is C net. C net is answer of whom? Answer of CS and C4. How are they connected in parallel? So what will be same voltage? So you can pick up the previous voltage and apply on both. So V net and V net. Okay, now solve it for C4. For C4, for every capacitor you should solve if asked. They have asked for C4, so I'm solving it for C4. C4's value was how much? 6 microfarad. And how much is the voltage? We have just seen it is 10 volt. So I can find out charge on it, which is CV. So my Q4 will be ready, which is one of the answer. It is 6 into 10. It is 60 microcoulomb. This is my one answer. Charge on fourth is asked. Now this I have solved for fourth. Now you should solve for CS2. CS. CS. How much was CS? I remember it was 4. Okay, it was 4 microfarad. And what is the voltage? We have just written 10. So what is charge on that S? This is CV, so it is 40 microcoulomb. So see, on every capacitor I am finding out CVQ. Okay, now I have to go to the previous diagram. The CS, whose answer is this CS? So go to the previous diagram. So CS is answer of these two. So they are in series. So what will be same charge? So you write charge here and charge here. And just now how much charge I have calculated as 40. 40 here and 40 here. Do you need any quantity related to second capacitor? No, then didn't ask. Then come to the CP only. So what was the value of CP? If you remember, it was 12 microfarad. You should check. And voltage you don't know. Charge you know is 40 microcoulomb. So you can find out the voltage because voltage is missing right now. So voltage will be Q by C, which is 40 by 12. Okay. Now C2 के बारे में कुछ नहीं पूछा है तो forget about it. CP is answer of whom? CP is answer of C1 and C3. How are they connected in parallel? तो voltage same हो जाएगी. Voltage लिख लो ये वाली 40 by 12 and 40 by 12. Have they asked the question about C1 or C3? They've asked about C1. So solve for it. How would you solve? V is 40 by 12 and C1 was how much? 6. So you can find out charge on it. It is C1V. Then you can find out the ratio. So this is how it will be done. All diagrams are used in depth if you wish to do it. This is 33rd question, first part. So let's see. This is equation of voltage, which is 100 Sine omega t. So this is V naught and is 100. So we have been given this. What is the self-inductance of the inductor? So graph is given between XL and frequency. It's written frequency. So you can pick up any two readings. I am picking up this. So how much is XL? 20. And how much is nu? 100. So I can find out XL is opened as omega L. XL is omega L. Omega is opened as 2 pi nu. So you can substitute XL, which is 20, 2 as it is, pi as it is, nu 100, and L. 2 and pi and 100 you can take down. So L will come in Henry. Henry. So L should come in Henry. The first part is this much. Now let us see the second part. Second part of the question, if the AC source is replaced by battery such that voltage is small, then what is the inductive reactance? Replaced by battery. Battery means DC. Battery means current is DC. So frequency is 0. So XL, which is omega L. So omega can be opened as 2 pi nu into L. Omega is opened as 2 pi nu and nu is 0. So XL is 0. So this inductor will offer no opposition. No opposition. Full you should write. This inductor will offer no opposition, hence it will behave as conductor. So this is second part. So what is the inductive reactance? 0. This is the question they have asked. What is the inductive reactance? 0. And give reason is frequency of DC is 0. So inductive reactance will come to be 0. Let's see third part. When the frequency is 50 Hertz, what is the average power dissipated in the inductor over complete cycle? So average power, you know, average power's formula is Vrms IRMS cos phi, and in inductor voltage leads current by 90 degree and cos 90 is 0. So average power dissipated over full cycle is 0. When it is simply one inductor, an inductor, so your answer is 0 here. Let us see the second, D part. Yeah, D part we should see. This inductor is connected in series with a resistance of 15 ohm and capacitor of this resistance is 15 ohm. Capacitance is 5 microfarad. L you have found in first part if needed. The frequency of alternating sources varied such that the power dissipated becomes maximum. Calculate the frequency and the phase difference between the alternating voltage and current when power dissipated is maximum. So power dissipated is again written as Vrms IRMS cos phi. For power to be maximum, cos phi should be 1. That means voltage and current should be in same phase. Cos phi should be 1, that is phi is 0. V and I should be in same phase. When is that possible? They are in same phase when XL equals XC and they cancel out. Then only resistance is left. So V and I will be in same phase. V and I will be in same phase when VL and VC cancel out. XL and XC cancel us out. So this is omega L, this is 1 by omega C. So this is omega square equals 1 by LC. So this is omega equals 1 by root LC. Frequency they have asked, so that is why I am doing it for frequency. 2 pi nu equals 1 by root LC, and nu can be calculated as 1 by 2 pi and 1 by root LC. So you can substitute your L. L you have found in first part. Calculation is longer, of course. L you can substitute from first part and capacitance has been given to you. You can find out that frequency in hertz. So let us see the next part of the question. Okay, it was up to here D. Let us see this question. An ideal transformer having ferromagnetic core of 2 coils having 500 turns primary. Number of turns of primary coil is 500. Number of turns of secondary coil is 50. What is the average voltage across the secondary? V secondary is asked, and V primary is given as 240. So this is simple. You can simply use V primary by V secondary equals N primary by N secondary, and substitute. You will find you'll be able to find out Vp. What will be the individual currents if the two coils if the secondary has resistance of this? So now you can use again resistance of secondary has been given as 20 ohm. So just now they gave you V secondary. Yes, so how much was V secondary? It was 240. Yeah, RMS voltage across sorry, V secondary was to be calculated, V primary was given to you. So just now you calculated V secondary. You calculated V secondary using this. How much you calculated? Let us substitute and find out. V primary was 240. V secondary is to be calculated. N primary was 500. N secondary was 50. So it was 10 and 10 was cancelled. So V secondary will go this side. So V secondary is 24 volt. Now V secondary is 24 volt. Resistance secondary is, you can see, it's 20 ohms. So how much is I secondary? I secondary is V secondary by resistance secondary. So 24 by 20. So how much it is? 1.2. 12 by 10, 1.2 ampere. So this is I secondary, and now you should know the formula already. N primary by N secondary. In current it is I secondary by I primary. You can substitute I secondary here, and these two values I primary will be found that way.